Hello, everybody, and thank you for joining us today for our briefing, 3 telecom operators who found gold in their data. My name is David Leichner. I'm the CMO at SQream, and joining me today is Arnon Shimoni, who's the product marketing manager at SQream. We're really happy to have such a big audience. I guess it's a very interesting topic, and really glad that you've taken the time to be with us today. Just a few housekeeping topics. First of all, next week we will be at the Mobile World Congress, Hall 5, stand 5E41, and we look forward to greeting all of you next week, whoever will be at the event. And if you want to set up a meeting in advance, please just email me at david@sqream.com and we'll find a good time for us to meet. Second, I'd appreciate if you'd raise your hands if you can hear me okay. Excellent. I see that there's no problem with the audio. That's a good thing. And lastly, if you'd like to ask questions, please just send them to me by chat, and we'll have a Q&A session at the end of this briefing. So just write your question over, and we will get to them when we get to the end of the briefing. So great. So I'd suggest we jump right in. So first of all, looking at the current telecom challenges, as you know, and I don't have to tell the operators who are on this call, there's cutthroat competition. The subscribers have many different options with which organizations they would want to work. As telecom professionals, you're looking at increasing revenue, reducing churn, and of course, reducing your operating expenses. And probably most of all, you're looking to differentiate yourselves by giving your customers a better experience, better services, better products for them to use. Of course, you're trying to simplify your operations as much as possible, again, to reduce expenses, to become operationally lean. And in order to do this, you're trying to maximize and to get the most out of the data that you have so that you can be more proactive and more innovative with the types of products and services you're offering to your customers. And lastly, you want to try to prevent and preempt as much as possible the customer complaints and the challenges that they're having in order that the relationship will be a good one. So what's the potential that you can gain from having better data insights? Well, as the McKinsey Group said, there's potential profit from applying data science is huge in telecom. So once you have a 360 type of view of your customers, you're able to, again, offer them better products and services, and you can increase loyalty, reducing churn. You can also create additional revenue streams. So for example, either yourselves offering advertisements and targeted products, or offering information to advertisers and other businesses so that they can better target, let's say, the users of your services. You can predict the periods when your premium customers are using their networks the most, and you can then take steps to relieve congestion to be able to offer them better internet, better data connectivity, better call connectivity, and so on. And what we found, and what the industry experts have found, is that the telecoms still are not leveraging enough the data that has been collected, meaning that in some cases you're pre-aggregating your data and doing statistics and analytics off of that data, but you're not able to get the benefit of really analyzing all of the raw data that you have. And most of the data is being collected still in silos across the organization, and getting a complete comprehensive 360 look from these fragmented or siloed data stores is often very complex, and it's often quite impossible. So you have a major challenge also in the latency from when you receive the data to actually being able to analyze that data. So for example, it can take 30 minutes to have data moved and integrated from your data sources, from your cell stations to your data lakes. It can take another 3 to 5 hours of ETL and cubes and aggregations and indexing to get that data into the legacy MPPs. And then from the MPPs, taking that data based on hundreds of CPU nodes, which are designed for analytics, it can still take a couple of hours to get it out to the data scientists in order that they can actually analyze that data. And here we're talking about up to 7 to 8 hours just for one report. So we think about how much more time that will take when we're talking about hundreds and sometimes thousands of reports. It's an immense time challenge from data to insight. So I'd like to hand off now to Arnon, who's going to discuss with you 3 different case studies of telecom operators who have found gold in their data. Arnon, would you please take the...
Sure thing, David. Oh, hi everyone. My name is Arnon Shimoni, and today I am the Product Marketing Manager for SQream. But I would actually like to tell you about a project I was involved in not too long ago. So let's jump right into it. I'm going to tell you about a large mobile operator in Asia. They contacted us because they had real problems with running ad hoc queries. They'd get their data piped into their columnar MPP, so their massively parallel processing database, but it was just too complex and slow to use for data discovery, which is something they really wanted to do. And the reason they wanted to do that is because they wanted to understand their customers better. As you know, mobile operators are making less money per minute or per byte than they did before. So really the main differentiator for a lot of these companies today is, seeing how they can improve their service and how they can target the right product for their customers and potentially also upsell them to a product that fits their needs better. So their current system was, as I said, just not really up for the task. They were facing a decision. Do they buy more of the current system? Do they expand it? And do they scale it out by adding hundreds of more CPU nodes so that it can do what they want to do? Or do they maybe go a different route and try something new? So as I said, they really wanted to match the right product for their customers based on their usage, where they live, what kind of stores and services they live by, and so on. With 40 separate CPU nodes that, they're loading all their CDR data, they're doing some sort of ETL process, then they're aggregating it, and only then is it ready for querying. And that can take up to 5 hours. And this happens every day. So it's almost 5 hours every day that they're spending just getting the data ready to be queried. And what we showed them is how with a more efficient analytics database, they could ingest it at about 2.5 terabytes per hour, and it will be ready for querying within 20 minutes. So that's the overview. But let's actually dig deeper inside and see what that looks like. So before SQream DB, before they called us over, this is what they had. They had their call data records and their SMS and their Wi-Fi and all these different sources being collected. And they would load them into their data lake along with the customer profiles and the value-added services. And what would happen at that point is it would be split up into separate silos. So billing would get their own, and profiles, customer profiles would get their own, support would get their own, and network would get a separate system. Now, each of these systems had to do a daily aggregate, and that was fed into their analytics database, which is a columnar database designed for analytics. But in the end, the result was that each of their daily reports took about 1 to 2 hours to generate, and once a month they would have to generate their monthly reports. So the fastest report that they would generate for that month took about 30 minutes, and the slowest report, their most comprehensive report, took about 5 hours. So all in all, it took them about 7 generation days to create the entire, their entire reporting, right? All the reports that they needed took about 7 days to generate. During that time, their system was just not able to handle, ad hoc queries or anything that's a little bit out of the ordinary. Anything that wasn't already anticipated and aggregated beforehand, they were just not able to do. So they were faced with this question: what do we do now? Do we enhance our data lake? Do we add more analytics databases? Like, what do we do now? So we actually, offered them, just load data directly into SQream DB. And I'll tell you a little bit later how that's possible. But it took about 25 minutes total to load a week's worth of data into SQream DB. So we're talking about 7 days of historical data, something that for 1 day takes them 5 hours. We were able to do in 25 minutes for 7 times the amount of data. And if you remember, the slowest report that they had, which took about 5 hours to generate, now only took about 10 minutes. So just from that, we were very, very pleased. And I'll tell you that this is the result. This is what they ended up with. They were asking, can you show us, we understand you loaded the data, fantastic. You've run a query, fantastic. Now can you show us where our customers are? And they had this question. They said, we have high value customers. We have platinum subscribers. Where do they hang out? Where do they spend their nights? Where do they spend their days? Where are they Instagramming more? Where are they using Facebook more? And for the first time, they were able to do this with Tableau. So what we did is we actually connected Tableau through ODBC to SQream DB in live mode. So some of you probably know Tableau has two modes. One of them is live mode, and the other is extract. So this is not an extract. This was running live. And this, for the first time, showed them this is where your high value customers are. And then we immediately saw their eyes widen up, and they're saying, can you show us students? Can you show us where families spend their time? Can you show us, we want to look only at nighttime. We want to see where they actually go. Can you show us where people who have been in a specific place, both for breakfast and for lunch? Can you show us? And you could see their eyes just widen up with all the possibilities that they could finally, get their hands on. And I didn't show you how the system looked, actually. This is the system. So beforehand, they had a Columnar MPP, which I will not name because we're not in a position to say anything bad about anyone. They had a very good system with 7,600 separate CPU cores. So this is a CPU-bound system, and it came in full in 40 nodes in 5 full 42U racks. Sorry, got my numbers confused there a little bit. And the entire SQream solution was actually in a single HP box. So we actually repurposed one of their older boxes, and we just told them, look, install 2 NVIDIA Tesla GPUs, and we'll show you how it's done. And the entire project was on a single server, which I think, other than the really fast, time to start the project, it took about, like I said, 25 minutes to load their entire data set that was relevant for this use case. Other than that, it's just a phenomenal cost savings because it's a single server. It's not 40 nodes. It's not 5 full racks. It doesn't heat as much as their 5 full racks. And by the way, I was in their data center and I saw the 5 full racks. They make a lot of noise. They heat up the room very significantly. And even if you just think about that, I think that's pretty incredible. So that's the first company. Let's talk about another company, which is a very big telecom in Israel, actually the biggest telecom in Israel, called Cellcom. And Cellcom had a challenge. They were actually, as with a lot of other telecoms, the money that they can charge for either call minutes or bytes being transferred over the network is always decreasing. But at the same time, they want to keep their network, really highly functioning. They want to make sure that the quality of service is high. Now, the problem they had is they had some cells that were not functioning 100% correctly. And they didn't really know why. Because when they would look at an individual base station, it was functioning perfectly. But they could see that, the calls aren't handed over properly, for instance. And what solution they were offered by the network supplier is they said, well, just install our really expensive hardware. We'll install network probes for you across your entire network. It's going to cost you a few $1 million, but you'll know exactly what's going on. Now, like a lot of other telecoms, they didn't want to spend this money. They didn't want to add more hardware to each of their base stations to find out what was wrong. They just, they wanted to troubleshoot it, and they wanted to do it very cost effectively. So they came to us for help, and we, together with them, designed a solution whereby we would actually collect the raw logs from the RNC. So RNC, the radio network controller, we would collect the raw logs from those RNCs, and we would copy them to SQream DB. We would run it through a parser and load it into SQream DB. Now, every 15 minutes, we collect all these logs from all the base stations, and we load them into SQream DB. And now, for the first time, they're able to look at a specific cell and see what happens to it. Like they're analyzing the entire area. And they initially found a specific cell that they were looking at, and they found that it was misconfigured. So they managed to, configure it properly and reduce the dropped calls in that cell by 90%. But not only that, now that they had this tool, they actually found 11 more base stations that were malfunctioning that they weren't even aware of. Initially, they actually started with Spotfire as a visualization tool for this solution. But afterwards, they figured out, they said Spotfire wasn't really doing the job for them, and they asked us to come up with a better UI. So we helped them build a UI in React Native with a Node.js connector. And now there are QoS engineers at Cellcom using this system, not just to analyze specific base stations, but also to drill down into specific customer requests. So, for instance, a high-value customer may call up and say, you know, I'm getting these problems. My phone is cutting off, or I'm not getting my internet is slow, and they can now drill down into specific customers and find out what kind of problems they're facing, which is something that they had to do very manually before by going to the actual base station and extracting the data from there. So that's a completely new ability that they gained. Our third and last company, and I'm sorry if I'm speaking too fast, you know, this is exciting for me too. I love these use cases because each one of them is very different. There's a company out in India called ACL Mobile, and they're a very large telecom provider. They actually provide what's called enterprise messaging services, and they're one of the largest companies in the world for this. They actually had a very different problem from the rest of the companies that we talked about. They have, they're enterprise messaging, and they have customers who are running campaigns and sending lots of messages through them. And they wanted to really look at their messages and see what's going on, how many were delivered, how many were rejected, get statistics over all these campaigns. And with the legacy database that ACL Mobile had, it was very difficult to do. It was so slow that, you know, self-service BI, so to speak, was almost infeasible. And as the company kept growing, this became more and more of a problem. And these customers were, you know, the ACL's customers were trying to run up to 40,000 queries per day on hundreds and millions of rows. And that was a real problem for them. So they asked us, can you help us with, sorting out this self-service BI thing? So this was their existing situation. They had their data sources, all the messaging tools, and that data would be loaded into a legacy MPP. Once again, I'm not naming the companies. These are fine products. Let's leave it at that because I see the questions on that. But these legacy MPPs were very, very difficult to maintain, and they simply could not provide the results that ACL wanted. Some of the queries would take many minutes to return for just 7 days of history. Now, when you're a customer and you're trying to look at, I want to see a month, I want to see 2 months, I want to see more, I want to see what happened, not just this week, but previous weeks. And this was just not possible. So they actually had to block this and not allow the customers to query more than 7 days. So once again, same story. We brought in SQream DB with 16 NVIDIA Tesla GPUs, and now the data is loaded directly from the data sources into SQream DB. I think it's about every 15 minutes, new data comes in, and now it doesn't take many minutes anymore. It takes about 9 seconds to return a query over 3 months worth of data. So now each customer can actually look at 3 months back and say which campaigns were better, which campaigns were not as good. Maybe they bought a list of numbers. We don't like talking about that, but sometimes companies do that. They buy lists of numbers and they want to know if the list was any good. So now they could finally do that. So not only was it 20 times faster, instead of minutes it takes under 10 seconds, but we're also looking at 11 times more data. So it's not just a week anymore. We're now talking 3 months worth of data. So that's also a very interesting use case. And in this case, SQream DB is actually the main database. So it's not like there's another database. This is not some Lambda architecture. SQream DB is the main database here. It's the system of record. So just to summarize the 3 value propositions that you saw across these use cases. our typical customer analyzes 20 times more data with SQream DB than before. And this is true for a lot of companies. You want to stay relevant, you want to stay on the cutting edge, you have to analyze more data. And I'll actually have a very nice slide for that in a minute. Most of our queries actually run a lot faster. So it's not just about analyzing more data, it's about doing it faster too. And why not, save some money while you're talking about it? Why not, reduce the cost of the implementation? Because if you have enough money, you can shovel all this money towards a very, very expensive dedicated hardware solution, and it will run very fast. But it's also very expensive, which means it's out of reach for most companies. So SQream, if you've, I'm sure most of you already know this because you've obviously signed up for this webinar, but SQream DB is a big data GPU SQL database. The SQL part is actually the most important part, not the GPU part, because everyone knows SQL. Every company has people who know SQL, who know how to, either they know SQL or they know someone who knows SQL. It's just everywhere, and it's so easy to use. And we said, SQL is the way to go. The GPU is the second important part of this, of what SQream DB is, because the GPU allows us to do things that we are simply not able to do with a CPU-bound solution. For example, when you think about compression, a lot of MPP databases do compression, but what they do is they only compress the archive data. So you say, I don't really care about this older data that's older than a month anymore. So I'm going to compress it so it's still available, but it's going to be really slow to query. So one of the things that SQream DB does different is actually we compress everything as it comes in. So not only can we do about 2.5 terabytes per hour ingest, but we also compress it as it comes in. So not only are we saving disk space by writing less data, we're actually making things faster. And this is something that the GPU allows us to do. We're saving disk I/O and we're saving PCI I/O by compressing everything, and the GPU allows us to do it practically free. It's a free operation as far as the GPU is concerned. It's just very, very fast. SQream DB, I said, is SQL based. That's one of the most important things in my opinion, not only as a developer but also as as a user for databases. Because it means it can fit in pretty much every environment. And this is just standard database stuff. It connects through Java, through Python, through R, JDBC, ODBC. You can connect Tableau to it, which we've seen. You can connect Spotfire. That's very standard stuff. But here's where we think this gets more interesting. We see this trend, and as data grows exponentially, and data does grow exponentially every year, companies are adding more and more data to their analytics pipelines. But a lot of times their CPU-bound databases simply cannot handle that exponentially growing data. They can scale to some extent, but when you start with 10 terabytes of analytics, let's say out of 100, then you're analyzing 10% of your data. And you can still remain competitive if you're analyzing 10% of your data. That's a pretty nice sample size. But as your data grows, let's say you're growing up to 500 terabytes, to 1 petabyte, if your system scales like CPU systems scale, then you're now only analyzing about 3% of your data. And in a few years, you're going to be analyzing 0.5%. And you're falling back here because you're not getting the full picture of your data. So we think, instead of making things faster, a lot of databases say, we'll make everything run fast. That's fantastic for a bunch of different use cases. But we think in order to remain competitive, you not only have to do it fast, but you also have to analyze more data. And if you ask any data scientist, you say, if I give you less data, will you make your models faster? Will that make it better? No one will say yes. They always want more data. They need to analyze the largest amount of data they can. So we say analyze a higher percent of your data if it's possible. And we think one of the ways to do that is with a GPU database like SQream DB. And before that questions comes up, SQream DB does scale. You can add more nodes with more GPUs. And these are all active. So if these are redundant, so if one of the nodes falls, the other nodes can take its place. And we can run on pretty much any hardware, be it from IBM, from Dell, from HP, Supermicro, Cisco, as long as it has an NVIDIA GPU. So that's actually the only hard requirement we have for SQream DB is an NVIDIA GPU. And to some extent, it also has to run Linux, but that's very, very common. It's not like an added expense. David?
So first of all, before I finish off with this slide, and then we take some questions that have come in. So just wanted to run through some customer feedback that we've received. As you can see here, some of these customers are very much squarely in the telecom industry, like Orange, like Cellcom, like ACL Mobile. You see that there's a couple of things that resonate here. Number one is the cost performance, removing limits of databases. The second is that you're able to do so much more and to achieve such greater analytics than previously they were able to do with the massive data that they have. And in the case of ACL, for example, they're able to give their customers actually the ability to self-service receiving historical data, much more data. They're able to receive it much more quickly, and of course, they're able to do this at a lower maintenance, or I should say, at simplified maintenance and lower costs. So, just before we take the questions and give you some answers, and I see that we've received several questions already, I just want to tell you that next week we'll be at Mobile World Congress. We really look forward to meeting all of you. If you want to set up a meeting in advance, Arnon, maybe you can just go to the next slide. You'll see that my email address, david@scream.com, or to arnon@scream.com, and we'd be happy to meet you. We'll have our system architects there as well, and they'll be happy to meet you and to discuss with you, any of the questions that you might have. So just to check out a couple of the questions that we have coming in. Okay, so we have one from Pablo, and Pablo is asking, what are the minimum hardware requirements to evaluate SQream?
Yeah, so in reality, you can run SQream on pretty much any NVIDIA-enabled hardware. We actually have some, this is a telecom-oriented presentation, so we didn't talk about like our homeland security use cases, but we actually have a customer running SQream DB on a hardened laptop with an NVIDIA GPU. So that's really the only hard requirement. For POCs, we typically recommend something that the customer will be able to grow with. So that's typically something like a Dell 2U server with NVIDIA GPU. But in some cases, we either repurpose old hardware or we use a workstation with an NVIDIA GPU. The NVIDIA recommend that you only use Tesla GPUs for this because they are a lot more robust. But from the SQream DB side, there's no real requirement. We actually have an implementation on ARM, on an ARM embedded computer that's coming out soon. It's not public yet, but it will be coming out fairly soon. Most of our developers run it on standard GeForce cards when they're doing development and testing. So it really depends on the use case, but the minimum requirement is basically that there is none. So I hope that answers the question, Pablo.
And Pablo, if you want to drop an email to one of us after the webinar, we'd be happy to speak to you more in detail about it. So Josh asked a question whether or not the webinar will be available for viewing afterwards, and yes, it will be available. It's being recorded. So I expect that by later today, tomorrow, it'll be up on our website and you'll be able to access it. We have another question from Joel, who asked, how long does a typical telecom implementation take? Arnon?
It can take about 2 to 4 days, actually. A typical implementation, usually what we do is we ask the customer to collect some data beforehand, decide what they want to do with the database. So we decide on KPIs beforehand. We will help the customer vet if we are a good fit or not. So just like with any other database, it could be that you need another database. So let me give you an example. Primarily, you're doing some sort of full text search inside a string column that is, 30,000 characters long. So a GPU database is really not a good fit for that. So in that case, we would help the customer vet the use case beforehand, and we would, because we don't want to waste our time, we don't want to waste the customer's time, we will help the customer vet if it's a good use case. So after that's done, the typical on-site or hands-on implementation is usually anywhere between 2 to 4 days. It takes about between 20 minutes to an hour to install SQream DB. And the rest is, loading the data and querying. So that doesn't take very long once the customer knows what they want to accomplish and once the data sets are already decided on. I mentioned we do about 2.5 terabytes per hour ingest. So typically when we do a POC, we try to limit the size that we're working with to somewhere around, let's say, 6 to 15 terabytes, somewhere in that range. And when we're talking about a data set that is that size, it doesn't take too long to load.
Great. Thank you.
So I hope that answers the question.
Alfred had a question whether there's any particular NVIDIA GPU card required.
I said we like the Tesla series. NVIDIA recommends the Tesla series, and we like it too. It's very robust. It's passively cooled. The Tesla K80 is something that we've installed so far quite a lot. Having said that, there are newer GPU cards. There's the Tesla P100, and there's the Tesla V100, which is brand new and actually quite expensive. So right now, our recommendation is actually for the P100, simply because it's a very good card and it's not that expensive. It's about $5,000 retail.
Excellent. Thank you very much. And we have one last question here. Actually, there's two I just see coming in. One is, how much data can SQream handle? Where are we with that?
Actually, that's a very good question. Our largest implementation is 1 petabyte, but there is no technical limit. Well, the technical limit is just extremely, extremely high, which I doubt we're going to see in the next, let's say, 10 years. We can grow with the data. Like I said, our largest implementation is 1 petabyte, and that's not even close to the physical limit. It's really as much as the machine can hold. So if you have a 1 petabyte storage, you can analyze 1 petabyte. If you have, 6 terabytes, we will analyze 6 terabytes. The GPU actually doesn't correlate to the size of the data. We recommend actually about 1 GPU per user in order to get 100% dedicated service. For most of our customers, we usually do about two users per GPU.
Excellent, thank you. Lucia has a question. What are the requirements of the data set before loading into SQream?
It just has to match the DDL. Like any SQL database, you create the table beforehand. If it's, for instance, if it's a CSV, you just have to make sure that it matches and you load it. We prefer bulk loading. We prefer larger tables. Some of our customers have about 700 columns in their table. So you have a big, big file representing the 700 columns. It can be Parquet, it can be CSV, or it can be over the network streaming. So we typically use an ETL tool like Talend for that, and Talend will just pipe the data into SQream over JDBC. There's no other requirement other than the data has to match the structure. Like any other SQL database, we're a structured database, so we need everything to be in tabular form.
Okay, great. Actually, Pablo has a return question, follow-up question.
All right.
I have a time series database, ID, timestamp, attribute. Is it a good use case?
It's tough to say. We would have to look further into that. Like, for instance, if it's just one table, then yes. If it's 300 tables, still yes. The question is how you query it. What kind of queries are you running on this time series data? So SQream can do time series pretty well, actually. are, we're a columnar database, so we're pretty good at time series stuff, like a lot of other columnar databases. If we would need to dig deeper to find out, but off the bat, it sounds like we could be a good fit for a situation where you have ID timestamp and a bunch of attributes.
Okay, thank you very much. And we have one more question, which I'll actually take from Alfred. Another question. Pricing is on dataset size. Pricing actually is per terabyte. And the question is whether it's perpetual, subscription-based, and so on. This is something that we would have to have a discussion about. It really depends on the implementation. We try to be quite flexible to match the needs of our customers. Okay, and the one last question, and then I think we'll be out of time. What about the other GPU database vendors? How are you different?
Good question. We're constantly grouped with the other GPU database vendors, which I'm technically okay with. I don't mind it myself. But the truth is, we're very different. When you look at a database like MapD or like Kinetica, for instance, the first and very glaring difference is that they are in memory and we are not in memory. So that would mean, for our sake, that we don't need to be bound by memory. And if we look at, let me go back a little bit, because we talked about this company out in Asia, this Telecom, and we actually, with 6 terabytes of, we analyzed about 6 terabytes of data for them on a machine with 96 gigabytes of RAM. So we're actually not limited by RAM, unlike other GPU databases. At the same time, we're not going to be as fast. An in-memory database has the advantage of having the data always there, ready to be queried immediately. So they would likely be operating in the milliseconds range, while we would be operating in seconds. That's the kind of a time difference you would see SQream DB versus the others. Having said all of that, I think we would have an easier time scaling to a much larger data size. So 6 terabytes of storage with an in-memory database, you would have to have 6 machines with 1 terabyte of RAM, give or take, based on how the data is actually distributed and partitioned and so on. But 6 machines versus 1, personally, I prefer the 1, but it's going to be very highly use case dependent. If you need millisecond response times, you're going to go with an in-memory database. If you're just interested in doing more data, like getting higher throughput, I think SQream DB would be a better choice for that. But other than that, we share a lot of the same benefits.
Excellent. Okay, well, I'd like to thank everyone for joining us today. As I mentioned, we will be in Mobile World Congress next week in Hall 5, stand 5E41, and we'd really be very happy to see all of you there. And with that, Arnon, thank you very much. You did a great job. And I wish everyone a very nice end of week and a great weekend to come. Thank you.
All right, fantastic. Bye.